We have ignition, Kevin says. Welcome back to the Cycle World podcast. Kevin says, I'm the technical editor for Cycle World. I'm Mark Hoyer. That's what Mark Hoyer says. I'm Mark Hoyer, the editor-in-chief for Cycle World. And welcome back to the Cycle World podcast. This week's topic is what drove the designs of Harley-Davidson's Big Twins. So Harley Big Twins are a fundamental force in the motorcycle world. They've been thumping along, potatoing for decades and decades. Their birth was a response to things happening, technology marching forward, and every iteration since in a very Harley way, you know.
But usually there's a degree of desperation driving the thing because
that's, yes, Harley's been conservative. They don't just willy-nilly throw the book at things and change them for whatever. It's like we're a very tradition-based company, and we like repeatability, and we have a relationship now with our customers based on this 45 and its big twinness. Yeah. And here we are today. And I guess in Kevin and I's talking about this, it reminded me of some recent posts that we've made on cycleworld.com about the newest engine and then previous engines and, Milwaukee 8s and Evos. And there's an entire contingent that says, the 4-valve stuff just does not have the spirit of the old stuff. We hate the new bike. It just doesn't, it's not Harley. It doesn't sound like a Harley.
They've been doing that for decades.
Yeah, it reminded me of this punk band from the 80s who had a really big breakout album. And it was, hardcore punk. And they wanted to evolve musically. So their next album was not as punk. And they went to shows and everybody said, play album 1, because they were trying to promote album 2 at their show. They're like, album 2 sucks, play album 1.
Yes.
And then it was an interview with the singer. And then, so they did that and they played album 1, but they also played album 2. And then, they went off and did another album. And then they came back and it's album 3 and they're going to go out and promote that at all their shows. And they start playing album 3 and everybody's like, album 3 sucks, play album 2. And it just progress along. And that's exactly what happens with Harley. They change something and everybody's like, it's just not as good as it used to be. And like, meanwhile, back at the emissions.
There was a mechanic at Arlington Motorsports, our little hole-in-the-wall dealer. His name was Jack. And Jack said, Harley hasn't built a decent motorcycle since the Knuck. And that was, 1968. So great stuff. It's they say that change is hard for children. It's hard for all of us.
Yeah, and what I love about it is that there is a powerful bond and relationship in time, and where would we be without that?
Yes, and you must learn. You must learn to say, Knucklehead, Panhead, Shovelhead, Evo, Twinkie, and 8-valve. And if you get them out of sequence, you might as well not show your face around here again. And I was on the train coming home from the New York Motorcycle Show, and there was an older grandee of Harley lore holding forth to younger men about what was cool and what was not. And this material has to be learned if you are to be taken seriously in that operation. So, okay, motorcyclists are many different things.
I like your expression, the commonly used expression, older. And I always ask, older than who?
Yeah, not older than me.
Yeah, the same.
Oh, I should say older than I. What kind of journalism is that? So, in many cases, the reason for changing from one basic engine type to the next one was to secure cool, knock-free operation and mechanical reliability without oil leaks. Now, some people just say oil leaks are part of Harley-Davidson. That's not true. They're part of the way Harley-Davidsons were once built, and they have subsequently engineered around that. But there are physical mechanisms that produce oil leaks almost without any other cause than what I'm going to tell you about. Now, the original Knucklehead, which came out in 36 and which was authorized for development in 31, this is during the Great Depression. So you know that they had to have something behind this decision to build a new model in the middle of the Depression when there was no money. Nobody had any money. But the thing was that they would eventually put an aluminum cylinder head on an iron cylinder. Aluminum and iron expand at different rates. So as the engine warms up and as it then cools down after use, the gaskets between the head and the barrel and between the barrel, the iron barrel and the aluminum crankcase, get scrubbed. And the whole, what they call the stack, the head, the valve cover, the cylinder, is held down each by its own set of bolts. The cylinder has a base flange with little bolts, little sharp bolts. You can't get much stretch on those bolts. So when the gasket starts to be rubbed to death, the torque on the bolts becomes loose. And the cylinder moves around on the gasket because it's quite heavy. And the engine at each firing is sort of nodding its head quite violently. And I remember hearing that it was 90 G's of acceleration on the VR 1000 at the level of the intake port. 90 G's. That'll squash your puddings. Anyway, this is a matter of design. It is not a matter of the name on the company's production plant. And so many engines have been built with base bolted cylinders that are iron resting on aluminum.
Oh, I fixed a pre-unit Triumph, man. You pre-unit, post-unit.
Yeah, right.
Yeah, I mean they both were like that short bolt and the stretch. So what Kevin was talking about, you have a short little bolt, and there isn't a lot of stretch there because it's only this long. So if it's 10% stretch, that might be 10% of this distance might be yield.
Yeah.
Right.
Yep.
But if it's if it's of a 6-inch stud, then you got way more stretch. There's a lot more spring there to do the clamping. So you get you torque your Velicette, which, hey, take a drink. Did you torque your Velicette? Those go all the way through the cylinder head and down to the engine cases, and you torque them to, I think it's 18 or 21 pound-feet, and you're done. Well, you're not done. There's so many things to go wrong. But
let's go back to Harley's original decision to produce an overhead valve engine. They had lots of experience with overhead valves in racing, dating back to the 8-valve racers, and also to single-cylinder racers that were produced during the pea shooter era. So it's not that they didn't like overhead valve, or overhead valves were non-Harley. Don't think that. It's just that overhead valves present special problems. With side valves, the valves beside the cylinder with their stems pointing downward, is easy to seal up and lubricate. The tappets, the camshaft, the little shorty push rods that go to the valves, everything is oil enclosed. No leakage, no trouble. But when you put rocker arms above the cylinder, above the head, how are you going to lubricate them? Initially, well, this is a sports model. I'm talking about England now. You have to carry a little oil can or grease or something and squirt it, every 25 miles or so. Oh, well, that's a small price to pay for such jacked up performance. I'd love to have oil all over me. So the big problem that they faced was, how are we going to enclose all of this? Enclose the push rods, enclose the rocker arms, send oil up there. First of all, the engines that they had been making up until the original Knucklehead did not have recirculating pumped oil systems. They had total loss oil systems. So how are you going to lubricate the top end with oil that sort of drips? How many drips do you want to control? It presented problems, which is why putting OHV engines into production, the first step was a tall one. You had to really put out to get up that first step. So the background is, at the depth of the Depression in 1933, the thing hit in late 29, there were 13 to 15 million people out of work. There were 5,000 banks that were closing. A large percentage of 25% or so of farmers were having their loans foreclosed. Their property was being lost. And this was not a good time to say, let's build a new model. So why did they do it? They had strong reasons to do it. In 1929, they finally discontinued the intake over exhaust models. Originally, this was what the Dion Bouton engines were, that 20,000 of them went out of France all over the world to show people how internal combustion engines work. Here's one way to do it. It had a side exhaust valve, and directly above it was an intake valve that was held closed by a light spring. That's called atmospheric intake. So when the engine's suction stroke occurred, there would be a kind of stuttering as the low pressure in the cylinder pulled the valve open in little increments, kind of a brrrt. And it was hard to get those models to smoothly accelerate from zero because the valves tended to stick momentarily before they started tapping away properly. And later, a little tiny push rod and a little rocker arm was added on top of the mechanism holding that, surrounding that automatic intake valve. So that had just been discontinued, and they had bought, I'm sure at considerable expense because Ricardo never did anything for free, a license for Ricardo's turbulent flathead or side valve engine design. Now, this made a wonderful engine in one respect, and that is that by having the piston come up and squish part of the charge out from between itself and a flat part of the cylinder head, it made the combustion turbulence, which speeds up the burning, probably enough to outrun detonation. So that is where flatheads got their reputation for low speed. Them things got some grunt, man. They did.
Because they couldn't breathe.
Yeah. So that had just been discontinued in 29, and they had replaced it with flatheads like the VL. The VL was okay as long as you didn't want to go fast or far, because a side valve engine, the exhaust valve is sitting on metal that is part of the cylinder. So the heat from the exhaust valve and the exhaust port tends to produce a hot place in the cylinder wall. In 1922, Arthur Lemon, who was a peripatetic engineer, he worked for 4 different companies at different times. Lemon came up with an idea, which you can still see in any old Briggs and Stratton lawnmower engine, of leaving a complete gap between the structure of the exhaust port and the cylinder, so that cooling air could go through there, and it wasn't directly connected all the way down, just at the level of the cylinder head gasket. So they're getting a bad reputation for this engine, and their sales are dropping because of the horrible depression that is leaving so many people without money. See, from the end of World War I to 1929 was a boom time. When there's war, people don't have anything to buy, so they save their money. When the war is over, they go out and buy new stuff. And As a result, there was a glut of used cars. In 1933, you could buy a running car for as little as $5. So making a new motorcycle design, what are you guys crazy or something? But they decided that they had to do this. They had to build their reputation back up from what they had lost with the VL and other flathead models. So they made a conventional push rod and rocker cylinder head with a 90-degree valve included angle in a deep Hemi chamber, and it had quite low compression, something around 6-1. But the great thing about this is because the airflow into an OHV engine is so much straighter than it is into a side valve, where it comes out of the carburetor, it goes up to the valve, comes out of the valve, goes across the valve shelf and down into the cylinder. The power of this new 61E, it was a 1 liter engine, the V-twin, 45 degrees naturally, doubled the horsepower that people were accustomed to.
Well, 390-degree turns with the airflow. I mean, honestly, right?
Madness. That's bad city. So they had something. At the same time, they decided, okay, our engineers have been telling us for years, look, every car has a pumped recirculating oil system. On the nay side, there were people saying, oh, you don't want that because total loss, you're lubricating your engine with pure, brand new oil that's never touched anything hot. So you don't want to lose that valuable feature, do you? Yes, I do. I want to set it and forget it. Oh, look, I have oil. Let's go riding. So the VL had this total loss system. You either had too much oil, in which case there was a cloud of smoke trailing behind you, or you had too little and the engine was kind of, and even Harley engineers would say every now and then you'd have a seizure. So if they're admitting that much, it could have been an understatement. So they put all these wonderful features in, and they essentially doubled the power. They made a very attractive package. And that's what they sold from the introduction in 1936 until the war, and for a short time afterward. But when the war ended in 45, August, there was a building spree going on of 4-lane highways. In 1940, the Pennsylvania Turnpike opened. Around the cities, there were a lot of 4-lane roads being built. And what had been rural roads were being paved. So it was now possible to ride your motorcycle faster and farther. And with an iron cylinder head and an air-cooled engine, here's the problem. The only way an iron cylinder head with a certain number of square inches of fin area can get rid of more heat in the same conditions as when it was not being used so intensively is by getting hotter. The amount of air that's flowing through the fins hasn't changed, but in order to cool this thing that is now running hotter, the cylinder head has to become enough hotter than before to transfer that extra heat to the air that's passing through its fins. So what is the result? The result is shortened exhaust valve life, piston seizure, all the evils of fundamental engine failure. The bottom end's okay, by the way. So they decided that they would switch to an aluminum cylinder head. Now, every engineer worth his salt knew that millions of beautiful cast aluminum cylinder heads, some of them forged, not cast, were used on Allied big radial aircraft engines. Literally millions of those heads were manufactured. And they had push rods and rocker arms. They managed to lubricate them. And there's this stunning example there. So there was some trouble with the Knucklehead at first because it wasn't totally enclosed, or it wasn't well enclosed. And there were 1,900 motorcycles that were returned for an update kit. So they were really striving to recoup the reputation that they'd lost with the VL and the other side valves. So the big thing with Panhead is they addressed the heat problem by changing the cylinder head material from iron to the same aluminum alloy that was used in all of those big radial engines, alloy 242. Good hot strength, sort of okay for pouring, fills fine mold details and so on. At the same time, they decided to change the valve angle, which had been 90 degrees in the deep Hemi chamber. They changed it to 78.5. Why would they do that? They were aware that one of the things that makes the cylinder head hot is the transfer of heat from the combustion gas through the surface of the cylinder head and into the head material. So by making the chamber shallower, they reduced the surface area through which the head could be heated. So that was a step. And that step came with the Shovelhead. But the aluminum cylinder head was a big step. And it was a big improvement. But what they hadn't reckoned on was that very soon, the motorcycle of the past, which had no rear suspension and was started by might and main, you had to be an athletic young person to start a 1-liter motorcycle engine. So in 65, along came electric start. And of course, the Japanese had introduced electric start on their little twins in 1959. People liked it. People liked push button starting, even though there was some manliness value in kickstarting if you were young and athletic. So
it is a relationship builder, I must admit. Well, you
yes.
kickstart a Norton a certain way. A Velocette has a very, because you have one chance with a single, and the gear ratio of the Velocette Kickstarter, you have to get it just past top dead center and then very slowly push it through one stroke of the Kickstarter, and then you're in position with the best opportunity to start. So there is a relationship.
Your kick doesn't encounter compression for quite a while, during which the crankshaft is speeding up.
Yeah, you want to get that momentum, or else it's pow, and it hurts the old ankle sometimes, or
yes,
knee.
Indeed,
can hurt any part of it. But there is a relationship there.
Yes. So, but by Shovelhead time, there was electric starting. There was rear suspension. Rear suspension added 75 pounds. Electric starting added a similar amount. And now you've got a motorcycle underpowered for its weight. Now what? So they found themselves fighting problems like high oil consumption, short exhaust valve and spring life. Because when the cylinder head is hotter than you'd like it to be, the changes in metal parts are accelerated by temperature. And the exhaust gas that's passing under the lifted exhaust valve is wicked hot, and it contains stuff that produces corrosion. And eventually you have poor leak down. This thing kicks through really easy, but doesn't run all that well. So what the story comes down to, in many respects, is the steady improvement in the nature of the American highway system, because in the 1960s they built a lot of interstate highway. People could go longer distances, which meant that they could reveal the inadequacy of a design that was intended for an earlier, slower highway system. And this is natural. You build something, you think you've put an adequate margin for the future into it, and you find out that as the years tick by, changes mount up, and you have to redesign the thing because, okay, in 1966, they gave the shovel high-class exhaust valves made out of pneumonic 80A, which was a British-developed gas turbine alloy for turbine blades. And this was some pretty good stuff. It resisted corrosion. It had good strength even when it was wicked hot. And I'm sure it cost the motor company something to put those valves in there. They were taking steps to try to, let's call them palliatives. It's like somebody patting you on the shoulder when you've just been in an auto accident. Well, thanks, that feels better now. But they were getting to the point where they thought, 1980, they're saying we need a new design. Now, the AMF deal had happened in '69, and AMF, it's an amazing thing about capitalism. Capitalists want their enterprises to produce income. And in many cases, they may have to be ruthless in how they do this. And as a result, Harley quality may have slipped, or the perception of Harley quality slipped. How do we know which it was? So these palliatives were intended to cut oil consumption, to extend the lives of hot parts, and they were getting tired of it because every company has a warranty department, and the warranty claims are the reference that the manufacturer has to how well the product is doing in the field. And
that's weird because anytime I've ever called about warranties, they've never heard of my problem before.
Yes, indeed. Just like when when a particular brand, particular model of motorcycle shows any instability, if you go and look at the latest warranty bulletins, they call for reducing tire pressure 2 to 3 pounds and tightening steering head bearings. It's an old song. Anyway, this 1980 decision that we can't keep fixing this thing. It basically needs a complete redesign. They started in, and their lead guy came up with a design in about 3 months, which was remarkably close to what they actually ended up producing. And the focus of the Evolution engine, or Evo, was keeping heat out of the cylinder head. And the first thing they did was they had mercy on the poor piston. How is the piston cooled in older engines? By contact with the cooler cylinder. The previous engines all had cast iron cylinders. Iron doesn't transmit heat as well as aluminum, so they put aluminum cylinders on with iron liners that could be bored for oversize. Didn't want to shake people up too much with that Nicosil business. It's foreign, You don't know what their motives are, those people in other countries. So the next thing that they did was they radically reduced the valve-included angle. It was 78.5 in the previous model. They cut it to 58 degrees. And which is like this. This made the combustion chamber much shallower. It made it unnecessary to put the extra surface area of a piston dome on the poor piston, so less heat going into the piston because of less surface area, less heat going into the head because of less surface area. In a back page of Ricardo's wonderful, readable, and largely non-mathematical book, The High-Speed Internal Combustion Engine, you will find his statement that roughly 1/2 of the heat taken up by the cylinder head in operation comes from the exhaust port. So they made the exhaust port as short as possible. What a reasonable thing to do. And it hadn't been done before. I think in the 750 twins, there was some work on the cylinder heads that looked like they were thinking about the exhaust port length. But Evo had short exhaust ports. They were trying to keep the heat out of the head. Because why do we not want an overheated head? Because the hotter the head is, the faster moves the chemistry that changes the unburned fuel out at the edge of the cylinder into a sensitive explosive, which goes pop. This is detonation, knock, ping, tinkle. And what
Harbinger
detonation?
of rapid demise.
Rapid demise. Because what detonation is supersonic combustion. When a shock wave hits the stagnant gas on top of the piston boundary layer, stagnant gas clinging to the inside of the cylinder head, poof, that insulating layer is blasted away and you have a large increase in heat entering those parts. Why do we not want a hot piston? Because cracking, fatigue cracking, is greatly accelerated by temperature. The cooler we can make pistons run, the longer they last on every score. So what they were doing here was they were attacking the heat problem in the cylinder head on several fronts. Set that aside for now. Now the gasket problem. We have to stop these engines from leaking oil because it is an easy thing to point to. If it ain't got a puddle under it, it's out of oil. So, funny, huh? A lot of jokes. At the expense of hardworking, loyal Harley owners. We can't have this. So the long studs that Mark talked about were adopted, and they stick up out of the case halves, and it tempts people to pick up the case half as if the studs were the handle on a frying pan. But because the studs are long, it's easy to squeeze them too hard. And now they don't go through the holes in the head or the cylinder. But the thing that's wonderful about these long studs is they had to be made in two pieces so that you could get the head and the cylinder off with the engine still in the frame. The wonderful thing about them is a long stud is quite stretchy. So if you tighten it up to a certain clamp load, when the engine starts and warms up, the crankcase, the head, the cylinder are all a little taller than before.
And importantly, they're all aluminum now, so they're expanding at roughly the same rate.
Yep. These parts are increasing the clamp load only slightly because the long studs are much springier than a short stud. And for that reason, the studs do not yield. They're stretched elastically so that when the engine cools off, you return to 5,000 pounds per stud of clamp load, or whatever the number is, and you don't lose the gasket. There were dowels. They doweled the cylinders to the crankcase so that they didn't jiggle around from the inertia of the engine nodding its head with every firing. Incidentally, on the R3350 engines that powered Sky Raiders in
Mm.
Vietnam. Each time a given cylinder fires at the level of the intake port, it kicks to one side 20 thousandths of an inch. So there's that waving of the cylinders. So we wonder, why did earlier Harleys have terrible problems sealing the Y manifold onto the two cylinders? Because the cylinders are moving. Tough one.
Sky
So
Raider, folks. Oh, beautiful plane. Just a great sound. And a Sky Raider carried a bigger bomb load than the B-17.
yep,
And
on
it had
one engine.
one engine. It was a single engine, multi-use. Sounds great. I see them at air shows occasionally. It's not the most popular warbird, but it should be. It's a great aircraft. It was
Yep.
a real workhorse during Vietnam too.
So they're really thinking hard about product durability because they want to erase this bad image that Harley had during the early post-war years. And they set as a goal, and were able to attain it, of making the Evolution engine survive a 100-hour full throttle test. Now, imagine the testing. Imagine the gasoline that it would burn in 104 days of operation at full throttle. It should be able to do it. And the reason you test like this is because it's the same reason that you race. Heavy, hard use exposes problems quickly. So if you can pull one off the line and have it survive a 100-hour full throttle test, not a special engine that they pull out from some secret laboratory.
What do they call it? The most stock it possibly could be. That's blueprinting.
Yes, the most increasing stockness. So with these changes intended to reduce cylinder head temperature, they could increase the compression ratio, because with the cylinder head running cooler, detonation was less likely to occur because the temperature driving it had declined. They could increase the compression without running into detonation, which compression ratio helps your engine boost torque at all RPM. Unlike cam timing, late valve closure, lots of overlap valve timing, those are RPM dependent torque producing features. Compression boosts torque everywhere. And this is what you want for a heavy motorcycle, because you have to, without a lot of clutch slip, easily heave the thing into motion from rest. And if your customers can't do that, you'll hear about it from them.
Yeah. Well, it's why our crankshafts, our crankshaft assemblies in Harleys would be, whatever they are, 40 pounds or more or less. But they're big and they're heavy, and they're there to maintain that inertia so that when you do release the clutch, it's transmitted into movement. It's translated, that inertia helps, and then you're popping along and got your compression. Well, you talked about the 100-hour engine, reminded me of Royal Enfield, and Royal Enfield's big change in 2008 to their unit construction 500cc single air-cooled. They unitized the engine. They changed the design from basically a 55 Royal Enfield, separate gearbox and all the things that it had to be this ancient piece that they were still kind of nursing along. Their goal was for a motorcycle, that 500, to go to, in production form, to go 70 miles an hour all day. I think it was 70 or 75 all day. Yep. You could just get on that thing and just make it go. And huge deal. And that was their basic goal for their customer, because, they needed to do something new and different. And they automated a lot of their production and got CNC sealing machines. But the goal was shedding heat and making a good running engine.
Now, 12 or 13 Harley executives bought the company back from AMF,
This is very important because they undertook this redesign. They knew they had to at a time where it was depression. Like for Harley, it was
Yes.
precarious times and a
It was
leveraged buyout.
tough.
A
It was
leveraged
tough.
buyout in '81 when house like money was really really expensive, so they leveraged that. Being leveraged is we borrowed a lot of money to make this happen, and the rate that you were borrowing at for a house was like 13 to 20% for a mortgage.
Yeah.
It was a bad time to be leveraged, but they put it on the table, and they
So this was
came out with
very much like the original risk that was taken to produce the 61E during the Great Depression. But they had to do it. So this forced them to look into ways of cutting production cost. What did they do? Critics said they adopted Japanese methods. Not true. Just-in-time statistical process control and the rest of it were in use in American war production plants in World War II. And when the war ended, manufacturers said, people have so much cash, we don't need all this fancy stuff. People are going to just flock into dealerships and buy them out. And that's what pretty much happened. And the result was that there might be as many as 30% of the cars produced had to be reworked. That is, manufactured not once, but say 1.1 times or 1.2 times. Costs up, bad city. So what they did was they adopted just-in-time parts acquisition. Instead of buying 100,000 widgets and having them in taxable inventory, possibly forgetting they were there or designing future parts that wouldn't fit with these widgets. And these things have happened. These are great stories that people tell about. Anyway, they were able to save something like $20 million in a short time by adopting these methods, and they were able to offset the losses they had in the first year, which made them look good in Wall Street. Hey, these boys are progressive. They're coming. Let's look into this.
well,
Well,
my old friend Jerry Wilkie said, if you take care of Main Street, you're also going to take care of Wall Street. So they were making a good motorcycle that people wanted to buy at that time.
yeah. Now I remember going to Aspencade once upon a time and talking to people. And one man in particular stood out. He said, well, I'm riding this Goldwing here because it goes. He said, Harley's going through a bad time, and I hope I'll be riding a Harley again one day. But right now, I've got to get where I'm going, particularly because I've got my wife on the back of it. And it caused a lot of people to rethink their touring ride. So, I mean, if you've got pistons nipping up, or you've got exhaust valves that are guttering, or you've got heavy oil consumption, quarts and quarts of oil, having to carry oil with you on a trip, this was something that's unheard of today. But people were doing it. That's what those big, I used to call them beer carriers, they're oil carriers at one time.
Oh yeah. No, a new motorcycle, new car. Check the oil all you want. Boring. I mean,
Yes.
there are a few motorcycles that will consume some oil, but it's nothing like the old days.
Yeah. And a lot of that oil consumption was back in the flathead side valve days, was because of cylinder distortion. Cool air hits the front, but there's nothing that makes that air go through the fins all the way to the back. The air kind of likes to bounce off. Oh, it looks tight in there. I'm not going in between those fins. What if I hit my head? So the back of the cylinder is hot. The front of the cylinder is less hot. So the cylinder can't be round. And it was true of aircraft engines, all those huge radials. You never dared to walk under an engine while wearing a white shirt because a big blop of horrible black oil that could never be got out. It's like chain grease. You know what chain grease does to a cotton shirt? Stuff would fall on you. So anyway, at this point, farther on, they're looking at the competition because a lot of Harley riders had switched to Goldwing and other alternatives, BMW. That meant that Harley had to match the performance, power to weight, had to match oil consumption, reliability of all kinds. They had definite competition at this point. So this is what the twin cam was designed to accomplish. It was to do the impossible, basically, because a lot of people will tell you, don't try to make an air-cooled pass emissions. Just don't do that. But Harley had to do it.
It's worth mentioning the Nova, which is probably a separate podcast, but Harley looked at a 4-cylinder design around this time.
Yes, that was before they had that wonderful ad agency that said, you've got something that nobody else has and you don't even know it. You have America. You have American nationalism distilled into solid form. People love these American motorcycles. Well, once they were tipped off, the idea of Nova, which was originally, we've got to make Japanese bikes to compete with Japan. No, we've got to make Harleys that are true to the idea that people have of it.
Also true today, by the way.
Yes, absolutely. Which
more true than ever.
Meant cooling fins. And I remember my dad took me to New York on my right around my 7th birthday, and we flew on a Convair twin powered by 2 air-cooled R2800s. And as we're approaching the airplane, I could see all these wonderful fin shapes. And I thought, oh, I want to look. Can we stay here and look? No, it's boarding now. And we got in and took our seats and off we went. But yes, cooling fins. For some people, they're very important. On those aircraft engines, cooling fins received the most detailed development. It was wonderful. I've been through all these NACA reports. It's just wonderful to see the things that they had to do to make, basically they had to do the same things that Harleys had to do to preserve their air cooling. So,
well, there's an entire discussion about fin pitch, ducting, what kind of fin pitch will air just freely fly through. And when you look at a radial aircraft engine, particularly something like the big Corn Cobs 4360s, where it's a 28 cylinder, which I've witnessed hanging from a gantry in your shop.
Yep.
Not one, but 2.
Things.
Yeah,
they're
3
great. Eventually.
Yeah, and you've got to duct cool air through all of those things, and then you need to keep them cool. And you told me this that they were cutting cylinder fins with a saw on a guide that would run the saw, and
a cam-controlled machine. Yeah,
cam control cutting. I mean,
and there was a different cam for each fin space because the shape underneath it had to be different. So they had to go through hell to cool those monsters. And of course, every cylinder had to have cold air. You can't let air go through the fins of one cylinder and then think you're going to cool another cylinder with it. That's why parade mode exists. Because in parade mode, the rear cylinder gets really hot if you don't have parade mode, and it starts to smoke because cylinder distortion just won't let up. The laws of physics, you can appeal to them. Oh, please. They don't hear you. They're immovable.
Yeah, that's why turning off the rear cylinder has become
so they turn the rear cylinder off, and as you're sitting there in horrible traffic and looking at your watch, I'm 7 minutes late already. What's happening? At least you're not smoking. So it's good. Anyway, they had to come up with more powerful engines to keep up with the competition. They didn't want to be in the position of saying, yes, but it's a Harley, What you lose in performance, you gain back in coolness.
Well,
Tradition.
it was the same thing
Greece.
that happened in the 50s with Britain, because Britain was like flooding our market. Britain's manufacturing was you export because they needed to bring money back to Britain. So we
They
need to
told them
sell.
you have to export 70% of production.
And so Bonnevilles are just coming across,
Yep.
and they've got qualities that people are enjoying. And they too switched to aluminum cylinder heads for sure in 58.
Yep.
57 were iron heads still, but this was happening, and Harley had to do something. They had to compete with the British, and then they didn't have to compete with the British, but now they got to compete with the Japanese.
Competition is something that businessmen will toast at the Kiwanis. But when they encounter it, it can be tough because the Japanese were intent on making money just as Harley-Davidson had to be. If you don't put money first, you may not be doing anything. So the twin cam, they had to tackle this problem of how do we make an air-cooled engine produce the necessary performance to match or exceed the competition, and how do we get the EPA to pass it? How do we make the engines durable enough to maintain this quality? So they at first found, pistons are running really hot and the cylinder heads are hot, and we need an oil cooler. We got to have an oil cooler. I mean, air-cooled engines, the aircraft engines, 30% of their cooling was delivered to the oil cooler. So it just made sense to the engineers. We'll put an oil cooler on. No, said Styling. We don't like an oil cooler because we think our customers don't like an oil cooler. It's an add-on. It makes you look Japanese. They've got stuff hanging in front of their engines. Ugly stuff. We're not going to do that. So the engineers had to come up with a compromise. Sometimes the story is told that they just reduced the flow of oil to the heads and let them get hot. No. What they did was they built some test parts, and they found that if they increased the fin area, square inches of fin area per head, they could bring the temperature down. Now let's go to those stick in the muds over at Styling and see if we can work out a compromise. Styling didn't like the big fins either. But if you tell them our engine program will fail if you hold back everything, a compromise was worked out.
Oh, that's the classic tension in motorcycle design, is often engineering and styling. It's just if you go to the superbike side, it's like, well, what we need is a 30-liter airbox.
Where?
Where are you going to put that? So there's this, and the exhaust system, you need to pass sound emissions, and you got to fit a catalytic converter in there. And where are you going to put all that? And, they've got these huge boxes in between the engine and the rear wheel, and there's all kinds of different strategies. And they're,
Eric showed them how.
Yeah.
With that torpedo bomber muffler system of his. And it was widely adopted. It's still in wide use. So they made that compromise, and they also began to squirt oil up to cool pistons, because you've done what you could for the pistons by adopting an aluminum cylinder, and they're still too hot. You have to squirt oil on them. And that's what was being done for the giant radial aircraft engines at the end of World War II. They had one squirt for 8 of the pistons and 2 squirts for the master rod piston, which has extra side thrust on it. So this engine was made to pass a 250-hour full throttle test. So all this talk about, oh, they made all these fussy little changes, they did this and that, and it's such a bore. No, it's not, because it has a result in enhanced reliability, resistance to detonation, long exhaust valve life. These are adult engines. These aren't some kind of gussied up thing that in the aftermarket where they bore the cylinders out until it's a stack of washers, and you get a mail order stroker crank, and you make this monster engine, makes good performance for a while. The factory, in order to back this product with warranty, has to be pretty sure they're not going to lose big money fixing problems that they should not have sold. So this is what I have to say to Harley riders who are upset by change. We're all upset by change, but there are good reasons for these changes. Really good reasons. So even with all this attention to detail, they ran into the same problems that the engines on the B-29 bomber did. Even with the latest of 5 different modifications to the cylinder head, even with the latest of 5 successive designs of air baffles to make sure that the air does go through the cooling fins, they were still having terrible problems. Well, what Harley did about it was Project Rushmore from 2013. If something's running hot, cool it with liquid. Antifreeze is something like 600 times denser than air. So it can really take away a lot of heat per gram of cooling material circulated. So they made passages around the exhaust valve seats, and they circulated either oil, 1200 Sportster, or CVO, has actual antifreeze, and there are heat exchangers in the front of the fairing.
Like little pods.
Yep.
Yep.
Like a bathroom heater.
Strategic cooling.
Yep.
And easy to hide.
Sometimes called topical, because it's just for a certain area. Like you put mercurochrome where the injury is, you don't put it all over your hand. So this gave them power over these problems of overheated exhaust valves, overheated cylinder heads. The oil jets gave them power over piston temperature. They could say, we now want to reduce piston temperature 25 degrees. They had the way to do it. So this brought us to another level of competition. What happens when a 2-valve engine competes with 4-valve engines? Harleys for many years have suffered the embarrassment of having thunderous bottom torque to get the motorcycle moving and to accelerate up on ramps and to deal with passing situations. But as the engine revs up, it wheezes out, because the cam timing that produces that wonderful bottom torque doesn't deliver enough air to the engine to make it top end satisfactorily. What do you do if your customers are saying, this thing seems to not have a lot of pep? I rode my friend's XYZ motorcycle and it went right along. I kind of like that. Harley guys didn't want to hear that story, but they did hear it. So they had to come up with an answer. Now, with 2 big heavy valves, there are limits to what you can do in the way of suddenly accelerating them from closed to full lift and from full lift to closed again without the valve bouncing, without impacts, without bad resonances in the valve springs. All of your problems, Keith Duckworth enunciated many years ago, are divided by the square root of 2, roughly 1.41, when you adopt 4 valves in place of 2. Because 4 valves have so much more perimeter distance around each valve than a single valve in a 2-valve engine, that they don't need much timing to flow a lot of air, because the amount of flow area that is exposed is the
Curtain area.
Yes, the distance around each valve times the lift. That's curtain area. And a 4-valve produces curtain area faster than any 2-valve. The shorter timing that 4 valves thrive on is the same shorter timing that heaves your motorcycle away from still into motion. Good one. 4 valves can be given a lot of extra area, so they outflow the single intake of a 2-valve, particularly when you take advantage of what is now known about valve control. They can open valves more quickly to a higher lift. Shorter timing, higher lift, excellent flow nevertheless. This is why the Goldwing has 80% of its maximum torque down to 850 RPM, because they too changed from 2 valves to 4 for these same reasons. So this is what the Milwaukee 8 sought to do. This was a way of having good passing performance, good starting from rest performance, and good performance towards the top end without that.
It was a really nice change. It was. I mean, 2 valves, for a big terrain bike, it's really nice. You could thunder off the line. I think they kicked the compression up pretty good with the twin cooled. They got a couple fractions of a point. I think 10-1 is what they ended up with, and it was a good engine. It was nice. But boy, getting 4 valve, you have that torque and you have that beautiful pull off the bottom, and then there's this really nice surge in the mid range.
And that's where you want it. You notice where the torque peak on all of these tour motors is around 3 to 3,500, because nobody wants the equivalent of a 14,000 RPM superbike on the interstate at 70 miles an hour. The engine is turning a fair number of revs.
Yeah. I mean, what the 4 valve gives you, a 2 valve torque curve, to exaggerate it, would be very bell shaped.
It rises quickly to maximum, and then it slowly slopes off as the flow area becomes progressively less equal to the flow.
And when
can't deliver it.
You throw 4 valves at it, it can still peak early, but it
holds up.
Holds up longer, and it just feels good. You just keep revving, and it feels like a happy engine revving up.
Just like those Gall-Dern BMWs and Goldwings. So competition is good for the public. They never cease saying so. And this is an example of how it has worked in this case. Harley faced riders who said, I got a Goldwing now, and here's why. Well, we're going to take that reason away from them so you can go back and buy another Harley.
And it's sort of the clandestine engineering that Harley's always practiced. I mean, until recently. But it was really, how do we keep this looking and sounding roughly how it has since 36?
Yes.
And how do we maintain that relationship and that look, but expand it to suit the times and to suit the competition without disturbing our relationship? And that's what they've done. They've really done a good job. If people always have kind of derided Harley, for not being up to date, but in fact they are. And in some ways they're being more clever about it because they're engineering for the experience in a way. What is it? Experience and relationship in a way that you don't necessarily have to with a Goldwing. You definitely have to hit technical targets with a Goldwing, and it needs to look a certain way and do the things you want it to, but it's a little bit different with the Harley. That emotional relationship.
Well, I always think when I hear Harley, I think of big radial engines in World War II aircraft. This is a P-47 or a Corsair you can ride on the street.
It is.
So great big cylinders, air-cooled cylinders.
Well, one of the higher up dudes in design used to take his team to Oshkosh, EAA Air Venture.
Yes.
To the annual fly-in, which is now a 600,000 to 700,000 person in a week event. It's the busiest air traffic control. It's the busiest tower in the world for that entire week. 10,000 planes, I think, come in, and it's full of radials, and it's full of air cooling and water cooling and I think there were 17 Mustangs or something there when we were there this year.
Wonderful.
And there's parts to buy, like you can go, you can buy, Duff cylinders, and you can buy pieces of the B-29, and they have all these things that you can get. But he would take his folks there, and he came back with I forget which cylinder it was, but the aircraft cylinders, a lot of them are a head and a cylinder as one piece. Mm-hmm. So you get this great big this visual signature, the way a knucklehead is. And he brought one of those and just plunked it down, in the middle of the room where all the guys are over their screens drawing or paper, whatever it was at the time.
Yeah.
But you're making an evocation of, historical relationship. So
another thing that they wanted to match was the acclimatization of riders to modern suspension and handling capabilities. They don't want, obviously, Harley-Davidson to fall behind. Well, it's got no suspension travel, so it's really stiff, and you have to stop to pee every 20 miles. That's not good design, is it? So a lot of mathematical analysis and so forth went into this, and in the account that I read, it said these suspension people were optimizing various figures of merit. It was all a lot of computations, but then they get to ride the result of fresh understandings of how a motorcycle responds to human control, and they said, this is better. This is really better. And I remember the words in the Honda Bentley manual from 1959, which I have in a bookcase behind me here. The words were far more superfine drive feeling.
That's great.
And I know that big, heavy motorcycles have become far easier to maneuver, particularly at low speed, because of understandings like this. All motorcycle manufacturers conduct similar development. Harley have put a lot into suspension and handling, and there's more to come. So these changes are not undertaken lightly, particularly designing a new motorcycle in the depths of the Depression. Amazing. Or designing Evo and launching it in another time of, we don't say depression anymore, it's too depressing. We say recession. It sounds like a cold. I'll feel better next week. It's going to be great. But Harley could have failed. Those 13 executives who put their names on the document were taking a big risk, just like the signers of the Declaration of Independence. They catch me, they're going to do bad things to me.
Yeah.
So Uh, this is, I think it's really a great story because there was risk and there was recovery and there was profitability. Right now, not so much. We read that Harley's having all this trouble. We hope that they'll be able to overcome it because we wouldn't like to think that the age of the motorcycle is drawing to a close. Don't even
No,
think it,
no.
because registrations during such times hold up quite well. People want to ride motorcycles. And if they have to ride a used motorcycle and learn how to clean carburetors and how to trace ignition faults, many of them will. And more power to them, because the more you know, the more you can do. So I think that these several designs, Knucklehead, Panhead, Shovelhead, Evo, Twinkie, twin cam, and M8 are, each one of them is a kind of gamble. And Evo was tremendously successful. It did recoup the company's reputation because it leaked far less oil. It was far more reliable. It didn't scrub its
Yep.
gaskets. It didn't
More of
need
what you want, less of what you don't.
yes. It didn't need a rebore every 20,000 miles or even 15. It was like a mature product, like an automobile. You expect to get in a car, turn the ignition, start, and go. It's just supposed to go. Oh, it's been 8,000 miles since I changed the oil. Well, I'll take it in next week. But it's set it and forget it. And while we may like to remember times that we have solved running problems on the road with few tools that we carried with us, and all these things make wonderful stories, but they're not so much fun when you're not getting where you're going.
Well, it's a sport that some
Yes,
still enjoy is
it
all.
is.
It's a sport that some still enjoy, but if you have to be at school to pick up your son and they're out at 3 o'clock, you don't have time to whap the side of the carburetor or wonder if the point
Yep.
slipped or whatever. It's just there's some things you want to be there. You need to be there.
Starts, runs.
Yep.
And the motorcycling experience used to include all of these troubles that have taken so many companies so many years and so much cash to put behind them. And I think it's a great story.
Well, there are many things like this. Ural sidecars. They've
Yep.
been making those since World War II,
Yes.
and there are all the old Ural guys. If you hold one of the pistons, they were like, well, it'll still run on one. You could like pull the plug out of it, and you could still ride on one cylinder and make it. And so when they first switched to fuel injection, they had to use a system that didn't rely on both cylinders firing or talking to each other.
Yeah.
It needed to run on one cylinder to appease the old
Yeah.
guard.
Sure.
It was a big deal with Royal Enfield. It's like, well, yeah, they're not that reliable, but they're very fixable. And in India, what you were talking about, maybe you can't buy a new bike. You need to keep your old one running. And that was one of the positives, is that you could make those run and you could file the points or do whatever it took. But there was a guard that felt like something was taken away from them with the unit construction 500, because it wasn't this. It had fuel injection. Gasp. But look at what Enfield's doing now. 1,000,000 motorcycles a year. They're not doing that with ignition points and
And
carburetors. And
Bajaj have told KTM that they expect to cut overheads by 50%.
yeah,
Now, what's that? What does that mean? It means that people in India know how to do that.
yeah.
We wonder, how can our Royal Enfields be so inexpensive? Because they know how to manufacture at lower cost than other outfits. Lower cost products, provided that they maintain standards of reliability, are better because more people can ride. How about that? Do we want a future in which only top 10% can afford a motorcycle because the first cost is so tremendous? This is not good. We want Royal Enfield to do what they're doing because it brings us more choices. So each time I study through one of these stories, like the Harley Big Twins, I learn a bunch that I didn't know before, and I see patterns that I wasn't aware of before. So I find this a rewarding process.
I do too. It's fun. No, it's really, I got a Big Twin sitting right over there on a stand. Mm-hmm. Look at it every day.
Yeah.
It's a wonderful segment of motorcycling. And anyway, thanks for listening. That's it for this podcast. Jump down in the comments. Let us know what you thought. Share it with your friends. That helps us. We'd love to spread the word. And we will catch you on the next one.